Hi, welcome to the first episode of this series teaching you IGCSE chemistry. The first thing you will learn in chemistry in IGCSE is the particulate nature of matter. In chemistry, this is the first concept that you have to understand, which is that all forms of matter exist in three forms. There's solid, liquid, and of course, gas. For solids, the particles look like this. They are arranged regularly, or you can say they are in a lattice arrangement. For liquids, the particles are touching, but they are not in a regular arrangement, as you can see here. For gases, the particles are far apart. Alright, let's begin with solid. The solid's arrangement is regular, or you can use the word lattice. For liquids, it is irregular. Similarly, gases are also irregular. Now let's talk about the attractive forces between each one. The attractive forces between solid particles is that it's very strong. And that is why it is touching. You can say that the particles are touching. As you may learn in other subjects, when you hold two balls towards each other and you apply forces to the side, the more force you apply, the closer the distance. So it is the same concept. Since the attractive forces, in this case, it would be the force pulling them in. Since they are very strong, they are touching. Now let's move on to liquid particles. The attractive forces, that's a certain way you can express this when you talk about the liquid. You have to mention that it is stronger than gas, but it is weaker than solid. This way, the particles are touching. The particles are still touching, yes, but they are not arranged in a regular formation. And it has also another factor in, which is movement, which we will talk about later. Now let's go on to gas. Attractive forces between gas particles, it is the weakest. So you can say the very weak. Right. Now let's talk about the movement of particles. In solid, they do not move. This is a very important point if you want to score the mark. They do not move, but they vibrate to and fro in their own position. This means they have very small movements, but it's not strong enough to move them out of place. They just vibrate like a phone. For liquids, we say that the particles are able to flow. Okay? Then for gas, I will just do that. Okay. For gas, they move fast in all directions. Now that we understand the key concepts of the three forms of matter, I will move on to the next topic, which is the changes of state. When you learn about changes of state, we try to grasp the concept of the changing of matter from one form to another form. So let me give an example. This is a solid and this is a liquid. Let's just imagine that. From a liquid to a solid, that is called freezing. If you put an ice cube in a refrigerator for a few hours, it will freeze, and from water, it will turn into ice cubes, as I said. But if you leave it out in the open, in room temperature or in hotter temperatures, it will melt, which is the change of state from solid to liquid. Then if you leave the ice cubes there for even longer, the water that has formed from the ice cube that has melted will evaporate. And evaporation is the change of state from liquid to gas. In the morning, when there's a certain phenomenon called the morning glory, it's when water vapors in the air condense back into liquid and form on the surface of leaves. Condensation is when gas turns back into liquid. And in IGCSE, there's one more that we have to know. From solid to gas and vice versa. And this is called sublimation. Now, let's talk about melting. As you know, melting is from solid to liquid. We have already given the example of an ice cube turning into water. And then now, freezing, we have also known water into ice cubes. But there is one change of state that is more complicated. The change of state from liquid to gas. There are two physical reactions that are possible that we will categorize as a change of state from liquid to gas, which is evaporation, as I have mentioned, and boiling. Well, what is the difference? Evaporation occurs at all temperatures. What this means, essentially, is if you leave a puddle of water out in the open, and you leave a puddle of water in, let's say, the kitchen where it is hot. Here, in the room temperature, the puddle will evaporate too at, let's say, 37 degrees Celsius, while this kitchen puddle is at 39 degrees Celsius. This will also evaporate. Both puddles of water will evaporate. This is because evaporation occurs at all temperatures. Besides this, let's go back to the particulate nature of everything. When a liquid evaporates, the key concept that you have to understand is that when things go right, in this case, melting, evaporating, they gain energy to change from one state to another. Further on, we will learn about another concept that explains this. But for now, all you have to understand is that the particles of the surface, which is over here, they gain energy from the surrounding. From, let's say, just the atmosphere, just anything there's nothing in particular, just the surrounding. That is the most general way to put it. Atmosphere, the surrounding, anything. So the surface particles will gain energy from their surroundings. And when they gain enough energy, they'll move faster. They'll move faster. And because they are moving faster, they are able to overcome the attractive forces between the particles. So a way to imagine it is that once it has enough energy, let's say this is an example of liquid particles. Once it gains enough energy, the surface particle, which is this one in this case, it will gain energy, and the next thing will be that it is moving faster. So let me this is just a small noting to show that it is moving faster. Once it moves fast enough to overcome the attractive forces between the particles, it will break off and it will leave through the surface of the water into the air as a gas molecule or particle. Now let's talk about boiling. What is so different about boiling? You see, boiling occurs at the boiling point. Without making this too complicated, let's talk about water. Let's go back to water. As we know, water has a freezing point of 0 degrees Celsius and a boiling point of 100 degrees Celsius. Right? So water will only boil at 100 degrees Celsius. It does not occur at a range of temperatures like evaporation. It only occurs at or at a further time from this, the boiling point. So 100 degrees Celsius and above. And another key difference, as you can see here, there are two differences. There's the range of temperatures that it occurs in, and evaporation occurs at the surface. Boiling occurs throughout the liquid. Of course, the ones that are nearer to the heat source will evaporate first. So let's say you heat a cup of water on a stove. Let's say this is fire, and heat is going up. Right? So the particles that are closer to the heat will gain more energy first. These will gain more energy first and rise to the surface where it will boil. So the main difference between evaporation and boiling is that evaporation occurs at all temperatures. That means if I have water now, it is evaporating. If you have water, it is evaporating as well. While boiling only occurs at the boiling point and above. So 100 Celsius, 101 Celsius, 102 Celsius, and so on. You get the idea. And I think that is it for today. Try to grasp the main points of the first two chapters, as it is the most basic concepts that you have to understand before going deeper into the syllabus. And the earlier you understand, the easier chemistry will be. Thank you very much for watching, and I wish to see you again in the next video.